I'm going to go over homework 4, which is array and pointer. So let's just jump into problem 1. Problem 1 just basically asks us to display an integer but in reverse. So if they gave us, 3, 2, 1, then we should do the reverse of it, 1, 2, 3. And so in this problem, I have a variable called user number, and I'm going to ask and prompt the user to give me a number, and with that number I'm going to store it into user number. And then I'm going to have a reverse method. I'm going to pass in that user number, and let's check out what the reverse method does. The reverse method takes in an int called username, and then we're going to toString it, because I find that if we go ahead and toString it and then just do a for loop and go backwards and then update and then grab like each individual digit, even though it's a string, and then store into keep track, and then just simply return keep track, but then convert it back from a string to an int, because this is returning an int. So that basically is what this code does. So it grabs the username, converts it to a string, goes to the for loop starting the last digit from user number, and then goes and adds it to the keep track, and then we return keep track. So let's test that out. Let's do 3, 2, 1. It should return 1, 2, 3. So if we scroll back up, it returns 1, 2, 3. Excellent. So problem 1 is done. Let's move on to problem 2. Problem 2 basically talks about let me get to it. Problem 2 is here, where we have to find the twin prime numbers. This one's really straightforward. It asks us, hey, can you find twin prime numbers from like 0 to 100? And we do that by going into a for loop up until 1,000, because it's asking us 1 to 1,000. And then we're gonna do an if statement inside the for loop to check if the current index that we're on is a prime number, and then also if the next two indexes over is also a prime number, then print out the in a coordinate format of x and y of the first index plus the next two index. That's only if it's both are prime. If they're not, it's not gonna print it. And both has to be true in order to be printed. So let's go ahead and look up, is prime. This prime is a function that returns a Boolean value. So it only returns true if the prime number itself is true. And I kept it that way because, yes, 1 and 2, for instance, are, okay, so for example, 2 is a prime number, right? But there is no twin pair for 2. But I just kind of resulted to its fundamental value of is 2 a prime number, yes, just to keep this clean, and I let the where it's being called at both the first index and next two index both have to be prime. So even though, like, theoretically, to achieve our purpose, we could just simply just say, hey, if it's 2, just skip it. I just wanted it to return its just make this do one thing, and one thing is to check a prime number. So I want to get that out of the way. Alright, so just diving in, we have to revisit what a prime number is. Prime number can't be divisible by 2, or it's when you do the modulo, it just can't be the remainder can't be 0. And so we know 1 is not a prime number, so regardless if num1 is 1, just ignore it. It's not a number. It's not a prime number. So it's just going to return false. And then 2, we know it's a prime number, even though it doesn't have a twin prime pair. But for just, again, going back to what I just said, to stick with one purpose per function, this just needs to see if it's a prime number. So in this case, we say 2, it is a prime number. And then the next one over, now this is what I was saying. If it's divisible by 2 and its remainder is 0, it is not a prime number. That should return false. So now going on to the more interesting part of this function is that we have a for loop. It starts at 3, and this basically starts at 3, and then it goes to check to see if num is is able to do the modulo of its index, and if it is the resulting remainder 0, again, it is not a prime number and should return false. But assuming it, is a prime number, then it should return true. And so if those two indexes are true, the I and I plus 2 is true, then it will print its format. Because it doesn't prompt a user input, we can just see here that it did in fact give us like all the twin prime numbers. Awesome. So now let's go to question 3. Question 3 is regarding of us like computing the weekly hours for each employee. So essentially we have a 2-dimensional array where in each row represents an employee of the number of hours they worked each day, and there's 7 days a week. So there should be like 7 columns. And I just put 5 employees. It really doesn't matter. You can modify this number, but just to work with the value, I just put in 5. So I put in 5 employees, and here's it represents like the total right here. What's in common represents the total number of each one, just so I can check to see if it's actually adding the hours correctly and then sorting them correctly, because essentially what this problem wants us to do is to return the descending order of the total number of hours that each employee worked. So if, for example, if this second employee with an index of 1, right, because it starts with 0 and 1, since he has the highest, actually I lied, it's the last one, so 0, 1, 2, 3, 4. So this 4th index should be start first, and then the index 1 here should return second, and then so on and so forth in descending order of total number of hours per employee. So we here have a number of employees, which is 5, so it matches the number of rows, and then the number of days per week, which is 7. So we have 7 days per week, and this is our 2-dimensional array that I've been referencing to. Okay, and we're going to be sorting that based on its descending total number of hours per employee. I have here 2 arrays, if you will, and arrays. And this one is different from this one because this one's 2-dimensional, this is just 1-dimensional. And the size of it only represents the number of employees. And since there's 5 rows, aka 5 employees, this size will only have 5. And it's the same thing with employee names. This just helps me when I sort them out later. So first and foremost, before even sorting them, I need to know the total number of hours that each employee worked that week. And so that's what the purpose of this for loop. It loops through each individual employee, so each row, and then we're going to have a variable called total hours, which will always be set to 0 for each employee. And then in this for loop, we're going to go into each day and total the number of hours per that employee, updating the value of total hours based on line 227. And then by the end of it, we should have an array for hours, employee hours, and employee names. And this actually helps update, say, hey, okay, for employee number 1, we end up having a total of hours of 39 hours. And so essentially what the total number of hours looks like will be like this, an array, and this will be like 39, 40, and so on and so forth. And that's all it was supposed to do. And the same thing with employee names. So essentially I store them based on their indexes. So this should be, like 0, 1, and 2. So it just kind of updates based on their index. And where we actually sort them is by using a bubble sort. Bubble sort, I'm taking in 3 parameters. I find that bubble sorting is the best approach for this problem. And bubble sort requires like a manual sort and requires a couple of for loops, which is why I made its own function where it takes in 3 parameters, which is employees, hours, names, and the number of employees there are. And so if we take a look at that, and returns, it does actually returns nothing, to be honest, but anyway, so this actually helps swap or okay sort in descending order of total number of hours per employee. And this first outer loop serves a purpose to control the number of passes in the array, while the second for loop is responsible for to compare like the individual elements, like in this case hours. But because also we want to return like the employee ID or index, if you will, I also swap by their name just so we can keep track of whose hours is what. So if we're swapping the hours, we're swapping also the employee's name. So that takes care of the responsibilities of the outer for loop, inner for loop. Now this if statement, the aim of that is to actually check, hey, is this first hour that I have less than that hour? If so, when we need to swap, right? But then if not, then we don't swap and we don't call that out that the swap method. Now this method did came from this algorithm right here package, so I didn't make that up. That kind of is coming built in. And just as I mentioned, not only do we swap the hours, but we also swap the names. So when we call this, the idea of it is to swap the descending order of total number of hours that each employee worked for that week. And so when we do that, we then want to display it, aka print it out. And so here I just called another for loop when it says it prints out the number of employees, which is 5. Say, hey employee, this is the employee's index or ID. So say employee 0, or let's say employee 2 had worked number of hours, number and the number and the number of hours. And so we could take a look of what it actually printed out based on the array that we gave it. So it seems to be like employee number 4 has worked the most hours with 48, and then followed by employee 1 has worked 40, and the least hours worked was performed by employee 2 by 20 hours a week. Awesome. That's pretty much it for problem 4. Now we're moving on to problem 5. Problem 5 that was problem 3. Now we're moving on to problem 4. Problem 4 is a cute little game where we just do a little tic-tac-toe, and the aim of it is to basically get a game going, and after there will be 2 players playing. The first player will always be an X, and then the second player will always be O, and the aim of it is to play tic-tac-toe. And I'm going to show you the code before showing the final output of this. So here we have player X, which is defaults by player 1 is always going to be played by X, and the player 2 will always be O. We have a counter here, and the reason why I put a counter is to keep track how many times, how many moves has there been. If it's 9 and no winning condition has been met, then it's a tie. This int variable called move, the aim for this guy is just to store the move of the player. Later we're going to do a check to see whether the move is valid, but for now the move ideally should be between 1 to 9, since that's how we kind of have it displayed. I'll show you what it looks like displayed. So it's 1 through 9. The board is actually numbered 1 through 9. So this is a 2D array called board, and the aim of it is to prompt or call create board. Now create board helps initializes the board, and I will show you what that looks like now. So to create a board, we just simply had to create pointers for both rows and columns, and so that's what this does, is creating the row pointers, and then we go into a for loop and actually assign like the column pointers for each tile. So that's what this does, helps essentially initialize the board like I mentioned. And also for display purposes, I also wanted to present like how is the user going to say, hey, I want to put X here. And to do that, I numbered each tile 1 through 9, and I just slowly like incremented the num up until 9. Now the first for loop, its purpose is to loop through the number of rows, which are 3, and then loop through the number of columns, which is also 3, and then increment it as you go. And then it returns the board, which is a 2D array. Awesome. So if we go back all the way to the bottom, we are going to continue, and now we have print board. Print board, so we grab the initialized board, pass that into print board. Now the purpose of this guy is to simply print out the board by putting the divisors and separating the title. So like you see this right here, these lines and pipes and stuff like that, that is being called, and that's being printed by print board. And so it loops through both rows, that's what the outer loop does, and then loops through columns, which is what the inner loop does, and then prints the individual like space and in pipe. Now, I want it to actually look like a typical, tic-tac-toe, so I only apply like the pipe in between columns 1 and 2, and then 2 and 3. And then if it's like 3, at the end of 3, I don't want to be a pipe because I want it to look like a traditional tic-tac-toe. And then for this one, this is also for display purposes, is to separate and distinguish what is the rows. So I wanted only to have this dashed line between rows 1 and 2 and 2 and 3. Now the reason why it's 0 and 1 is because remember, row 1 starts with 0 index and then goes down or increments it. So 0, 1, 2. Yeah. And then obviously returns a 2D board or 2D array. So now going back to the problem. Here now we say, hey, player 1, you're X, now you gotta go. And so then is playing is a Boolean value just to check to see, hey, are we still playing the game? Like, if so, then let's keep playing the game. And so I enter that in the while loop. Now, yes, I could have just put true here, but what's the fun in that? I just went ahead and did is playing. And so move here, it stores the player's move. So whatever number they put, it stores into move. And then these two serve the same purpose in the fact that, for example, we actually have to calculate the rows index and columns index, right? Because we've mentioned that this is row 0, row 1, row 2. This is not row 1, right? According to its index. So if a player wants to place a move on 5, its index is for index for row is 1, and then the index for a column is also 1. And that gets calculated in its respective function. Basically, these are the same, so I'm just going to explain one, and just know that explanation serves for both row and column. And so the idea is that to calculate the row index, we have to pass in that int, whatever number that the person has inputted, we grab that int, subtract 1, and divide it by 3, and that will give us the index for that row. Same thing for that math for a column. And then obviously they return an int because we're trying to get like the int. And then with that, we actually now check to see if the move is valid. And move is valid is a boolean, and it takes in quite a few parameters, one being the board, which was established here on 256, and then move is the player's move that they want to do, and then we've calculated the row and column index, which is what's called here, and then the player. We got to see what player is performing. Is it the X or the O? And then if that move is valid, then we update the board, and we'll show what that looks like, and then we increment the counter. But let's take a look at this is valid board. Here basically we have to make sure that the player is listening to the rules and inputting a move between 1 to 9, and if it's not, it's going to return false, saying the move isn't valid. Now, assuming that they did follow directions, and they did input 1 through 9, but let's say they want to put an X right here, but there's already an O on this third slot right here, then it's going to still return false because it's already, that spot's already taken by a previous player, regardless of an X or no. So it didn't have to be its own move, but it has to be like a previous move that was made there. Then the player currently playing cannot place that move now. And that too will also return false. I mean, anything else besides that, the move is valid. So that's great. And it returns true. So given that move is true, then what happens next? Well, then we're going to update the board. And how are we going to update the board is we pass in the similar parameters of what we did is valid, except we don't need the move. Okay, it's already valid. So we're going to update the board using the player, and then and just say, hey, okay, based on the rows and columns index in that board, we'll update based on that player's move. So if it was, player's O's turn, and we had a row that's of one, or index row of one, index or column index of also one, so 1 and 1, that'll be number 5. We'll update it with an O since it's player's O's turn, and we've changed to 5 to an O. And then we print the board because that's what the prompt wanted us to do, is to update the board and print it after each move. And I already explained what print board does, so I don't need to go ahead and explain that again. Now, after that, then it increments the counter. Again, remember the purpose of the counter. It's like if there was no winning conditions and it's already at 9, then that means it's a tie. Okay, speaking of winning conditions, these are the rules. Okay. So checking winning condition board is a function that's it's a Boolean function. And we have to pass in the board, and these are the winning conditions. Only if the element on index 00, index 01, index 02. So if this and this matches this and this, then that means that's true. Okay, and if it's true, that means we have a winning condition. And now we keep doing that for straight across row here, here, and here. We also check for diagonals, so here and here, and then columns is just up and down. Now, if any of those conditions are met, then it's going to return true. If not, it will just return false. So if it's true, that means depending on whoever was playing, so we have to check to see if the player, if the character of player is matched to X, that means player 1 has won, but then if not, then it's just player 2. Again, this is the tiebreaker that I was referring to. Not tiebreaker, but tie. If the count is exactly 9 and this wasn't met, then that means no one won, and we break out of the loop. Also, we break out of the loop if someone wins too. And then afterwards, let's say neither of them has happened because no one has won and it's not a tie. That means we're still playing. We're going to switch off between players. And that's it. And it keeps going until we get a break condition of some kind. Either someone has won or there's a tiebreaker. So let's go ahead and actually play some tic-tac-toe. So player 1, I'm going to press number 1 because I wanted to go on this top slot. And you see I got updated to an X. Now let's say you go and you're O, then you want to go put number 3, because I don't know, you want to put it right here. Okay, and it got updated to O. Now it's my turn. I want to do 5 because I want to go diagonal. But then let's say you saw that coming and you want to go 9. Okay, and let's say I'm being a dud and I'm going to put an 8, even though you had a win condition here. I just chose 8, and then you saw that and you go ahead and win 6, and that means you won. Awesome. And that's pretty much it for homework number 4.